I'm here at Harbour Air, and we're going to talk about the eBeaver electric seaplane. So if you could introduce yourself, and what's your role at Harbour Air?
My name is Erika Holtz, and I am the program manager and lead engineer for the eBeaver program at Harbour Air.
Awesome, thank you. And yeah, I'm here with my own blog, Tinkertry.com, but also EV Club of Connecticut. And we had the opportunity to see the Pipistrel electric airplane being recharged by a Ford F-150 Lightning, which was kind of unique.
Okay.
That even caught the attention of the CEO of Ford, just kind of showing how unique it is to have trucks chasing an electric plane to charge it every hour or so, right? So here we've got some more seats. This is by far the biggest electric plane I've ever seen. How many seats in that?
The aircraft is capable of 6 passenger plus pilot.
To be clear, it's a prototype, right? We'll head down there in a moment.
Yes, this is our technology demonstrator, so it's an experimental aircraft. Currently, only the pilot is allowed on as essential crew. We're flying under a special flight permit for experimental purposes only.
All right, and maybe I could have some try to capture footage of it taking off tomorrow if possible, because it'll be a little quieter.
Absolutely.
And that'll be fun. Cool. I'll make sure to get out here on time.
I think close to 5:15 tomorrow, somewhere around there.
Awesome. All right, and let's head on down. What a gorgeous dock and setting. And this city happens to have 1 in 4 vehicles sold are electric, so you're way ahead of the United States.
I didn't realize the numbers were that high.
Yeah, and in particular, I guess your electric rates are low at night. So as I look at this, I'm imagining if a plane's charging at night cheaply, cool, and then between flights, a lot of these planes are not moving, right? So, my gosh, it seems quite possible with these short hops, these shorter flights. What a great use case.
We are one of probably the best use cases as a gateway, an entry into market for this technology as it stands right now, because of the short flights, because of the area that we're in, because of the availability of clean energy, right? That our electricity is 98% hydro produced, and so we have clean energy coming in. We have the opportunity to fly short hops at low altitude, so they're lower energy emissions. So we are an excellent gateway for introducing the technology into the aviation industry.
Wow, all good points. 98% clean energy, unlike any other place in North America. That's really cool also. Thank you for pointing that out. So how did you get kind of connected with the company that's powering this
Right, so when
plane?
you get closer, you'll see their logo on the front. The company we're working with is magniX, and they are out of Everett, Washington. Originally, back in 2018, 2019, our CEO met their CEO, and it was one of those serendipitous moments. They had an electric engine and were looking for an airplane, and we had an airplane and we were looking for an electric engine. So they got introduced to each other through a mutual acquaintance, got really excited, and then told all of us that we were going to be flying an electric Beaver that year.
All right.
So we told them we'd have to figure out how.
And then, was that maybe a year or two ago? And then Oshkosh was last summer, right? Kind of the culmination of that?
No, this was 2018, 2019.
Oh, a long time ago.
Yeah,
wow.
This was quite a while ago when we went to first flight. Our first flight was in December of 2019, right before COVID. And so we had a bit of a hiatus during COVID. We didn't really fly or do much with the project through 2020 and 2021. Then we had a resurgence in 21 and 2022 and started flying it more to try and prove that this was a viable commercial product. So when we first flew it in December of 2019, due to the weight of the batteries and the technology that was available, we had calculated we were only going to get an 8-minute flight. And so as a technology demonstrator, that was acceptable, but it wasn't going to allow us to achieve commercial flights. But the really cool thing that happened was after we started flying it more frequently in 2022, we realized that the power required for level flight had drastically changed. We got a significantly improved performance in this aircraft due to the change with the electric engine, the new propeller, the more aerodynamic nose, the lack of cooling drag. We actually went from requiring 62% of maximum power to maintain level flights down to 41% of maximum power to maintain level flight. And this was important because that's the number you also use to calculate your reserve. So instead of requiring 65% of the battery pack just for reserve, we were able to get down to 35% of the battery pack being required for reserve, and we went to a 33-minute flight.
Wow, thank you for the summary there. I'm not a pilot, but I know on the Pipistrel it was something like in the US, it's certified to fly students for about an hour or something, or they're trying to get certification for that, excuse me. They have it in Canada, not in the US yet. California will probably be first. But it really has an hour and a half of flight time. It's just they have the half-hour FAA, I guess, guidance on.
It is a
time to find an alternative airport.
Yeah, it's a requirement. It's an operating rule that for VFR aircraft, you must have a 30-minute reserve.
All right.
It's something we're actually trying to negotiate with the regulators to get this defined differently, and I think Pipistrel has achieved that with Transport Canada. Instead of calling it a 30-minute reserve, they're calling it a 15% state of charge reserve, which makes a lot more sense from the battery perspective than giving a numerical value to it. So it's something that they're able to do pretty much under an exemption for that aircraft right now, but we want it baked into the rules as we bring these electric aircraft in. The operating rules need to be evaluated just like the certification rules.
Okay, looks like the crowd cleared out, so maybe we can walk over now.
Fantastic.
That's all right. As we're walking, I was just thinking about if you're at 10,000 feet and you have 15% left, that's one thing, but if you're flying low and there's mountains around you, that's kind of another. So it's not a little tricky, huh? It's not
exactly.
Just... Yeah, it's not so simple.
From our perspective, or at least my opinion on this, is that the reserves should be based on your operations, right? So how are you operating the aircraft? If you are an electric trainer like Pipistrel and you just take off and circuit and land, and you're always in a position to land at the runway, that should get a lower requirement for reserve. But if you're traveling further, or if it's going to take you a lot longer to get to base, depending on your operation or where you're going. So if we're just doing tours here, that should only require maybe a 15% state of charge or less than half an hour. But if we're traveling between bases, then you should have a higher reserve requirement. I think they need to be more flexible in their definition of reserve, and that's what I'm trying to tell the regulator that we should look at.
Okay, that makes a lot of sense. And then aerodynamic drag. I keep thinking about EVs and how sleek they are. And I think about some of these planes and how, well, pontoons aren't exactly aerodynamic,
no.
Right? But you said you already shaved some weight off. That's what's so fun about this. And also, all those years that have gone by, I imagine battery checks change a lot. So whatever we might see here is going to change before you have passengers on there, as far as space.
We have to freeze a design in order to take it to certification.
Oh.
And while we're working through certification, which is probably going to be about a 2-year process at this point, we know technology is going to advance, but we're going to have to pick a design and work with it so that we can use that architecture to get to certification. Then once we understand the certification path, we'll be able to swap out the technology for the newer technology and have a much shorter certification time just to get that component swapped out.
Gotcha.
So our expectation is we'll get to certification hopefully in 2026 with the battery pack with technology that's available right now, and that would allow for us to do flights with 2 to 3 passengers. But we know the technology of the batteries, we're working with a company right now that has more advanced energy density. They just haven't built any modules yet. But once we know the path, we can get their batteries to certification probably within 2027, and that would be what we would call our commercial aircraft.
Okay, so do you know the goal of how many seats will be available at that point when it's finalized?
Our goal is to get to 4 to 6 seats.
Okay,
right?
Sure.
To be able to make it equivalent to the aircraft is now. It's a 6-passenger seat aircraft with a pilot. So we would like to ideally get 6 passengers in it for we're calling it a 1-hour mission, where the reserve is included in that 1 hour.
All right, gotcha. And I see some equipment, so test equipment, but there's a bubble window, which is cool. And then there's the cockpit, right? So is that things pretty standard up in the cockpit there?
The cockpit is by and large the same. One of our design principles was to leave the cockpit and the pilot interface as unchanged as possible. Pilots are resistant to change. It makes things hard for them. So the more we can leave the same, the better.
Sure.
But what it'll have is the engine instrumentation will be replaced with a new display. We're still debating whether we'll need a secondary display for some of the battery information or whether we can fit it all on a single display. That's one of the purposes of our demonstrator is to determine, can we get away with one screen? What's the information we need on the screen? Do we need a second screen? So all of the controls and for the pilot will remain the same, but the display information to him will change, and that's one of the things we're investigating now.
Okay, we're just talking a little bit about, if something happens, I'm looking at how simple it is. So if something happens electrical, well, that's got nothing to do with the mechanical. Like, for example, look at this rudder. Just, wires, rudder. Here's a control surface, wires. So none of that changes. The hydraulics, how does that work? Is there anything hydraulic that's a critical system here, or the flight controls are just the pilot's arms?
It's pretty much all pilot efforts. Everything is cable or rods activated in this aircraft. It's one of the things that made it a really good technical demonstrator, is because if anything goes wrong with the electrical equipment on board, it doesn't affect any of the primary systems of the aircraft aside from the engine. And if the engine quits, the pilot can glide the aircraft and land it anywhere. The world is his landing pad, right? It's all his runway when he's flying this thing. So it was a great option.
Noticed a whole lot of GoPros. There's one. There is 2. That must be an amazing view as you're coming in for a landing. another one where you can see the pontoon splash down, which I couldn't quite see. My bubble window, I was looking the wrong way as we splashed down.
And then there's a fourth one inside that looks at the dash.
Okay.
The purpose of that one is during the flight, if there's something we want to look at that we think the pilot missed, if any of the messaging came up on the screen, we can look at the footage later and check to see if there's anything we need to pay attention to.
All right, and the propeller blades you mentioned, less drag. So I'm seeing 3 over there in the existing.
Yep.
Those are obviously bigger. You
Yeah, so
call
one
it
of
an
the ways-
eBeaver. What are we looking at for models behind us here, right? eBeaver was originally what?
It was a DHC-2 Mark I piston beaver.
Okay. All right, and then obviously way more passenger seats over there, bigger
Yeah,
animal.
so you can't see it right, but just to the left here is the single otter.
Okay.
So that is a single engine 19-seater, so that's a DHC-3 single otter.
So a little closer to apples.
Yeah, it's the big brother to the beaver.
Got it.
And then behind that is the twin otter. So it's basically the otter made a little bit bigger, second engine put on. That's a 19-seater.
Okay. This paint scheme, having a little fun with the battery pack painted on there and a motor.
Yep.
Just kind of pre-production fun, or
That was designed by the combined marketing teams for magniX and Harbour Air. magniX wanted to make sure that what their contribution was recognized, so that people would understand there's an electric engine up front, and then it shows the powertrain to the battery, and then of course the tail is our typical Harbour Air style.
Got it. And obviously it helped when you went to like Oshkosh with a whole lot of publicity to have all that. Make it real
stands
obvious
out.
to people that it's electric, right?
Yeah, it really stands out. Not many people paint their aircraft this bright. Most aircraft are kind of like our other ones, a lot of white. So when we were at Oshkosh, there were a lot of military aircraft, dark greens, light greens, black, and white. So our baby stands out a bit.
Yep, it was easy for me to spot too when I was looking out from up here at the convention center this morning. It sure catches your eye. Anything else? Nothing's modified down here then at all.
No,
It's just the innards.
The baseline aircraft is a 5,600-pound Beaver on 4930 floats. There is nothing changed external to the aircraft except for the long pointy nose there. Everything else is internal.
Is the scoop doing some cooling?
Yes, so it's a pretty standard setup where you've got a cooling loop and a radiator, so that takes air in and cools the oil over the radiator.
Okay. So let's see. How about cooling of the battery? Is that part of it, or?
No, the batteries, we can't afford the weight penalty to carry liquid cooling on board.
Ah, I see.
So we have what we call passive cooling. So there's some airflow due to wind coming in through the cowling, a little bit of airflow through the rest of the cabin. We might put some scoops on if we determine we need more active cooling.
All right, so we're talking about cooling. Yep, you were saying?
So one thing we're looking at is whether or not passive cooling for the flight is good enough, or if we're going to need to put some scoops on the aircraft to bring in the active cooling. It's one of the things we're testing on the demonstrator right now. So far, we are good for a flight with passive cooling. The problem is going to be, though, if you want to do multiple flights in a day. So to make this use case useful for us, if we're going to use it for tours downtown, which would probably be 8 to 10 times a day minimum that you'd want this thing to take off and land, you're adding heat when you charge and you're adding heat when you fly. And therefore we've got to manage that somehow, and that's where the problem is going to come in. So one thing my team is investigating with this technology demonstrator as well is ground conditioning. And so the batteries have liquid cooling provisions. They have ports in and out and a cooling plate inside. So we're going to hook up a system to flood the batteries with liquid medium, probably water. We're not sure right now. That's part of the investigation, is what is the best liquid for us to use. And we're going to use the temperature sensing in the system, because we're able to sense the temperatures of all the battery cells in the entire system, so that we would set up a computer that would look at the temperatures, and then adjust the temperature of the liquid medium to manage the thermals of the batteries. So the intention is you come in, you park, you just plug in the charger, you plug in the ground conditioner, it floods the batteries, it manages the temperatures, brings any differentials down into equality, and also brings it down to something like 15 to 20 degrees Celsius, the best temperature for dispatch, and should do that in the half an hour, and then it has to evacuate the system afterwards. And we want that done in the same time frame as it takes to charge, so within half an hour. And that's part of our project this winter, is to see if we can actually accomplish that.
So which manufacturer would you be working with on that kind of ground support for battery cooling while it's parked? Is that the manufacturer of the battery, or who would you be working with on that?
Primarily, it's just our engineering work alone. The only thing we need to work on is talk to the manufacturers of the batteries to ensure we don't exceed any pressure limits in the system. In order to flood it and evacuate it, we're going to have to put pressure into the system. We need to make sure we don't exceed any of their pressure limits, and that we don't use any liquids that they wouldn't want inside their components.
Okay, and then getting a little more into the looking ahead at adoption. Let's say it goes well and you have many of these someday. Getting a dock like this, both wired and plumbed, I guess, for cooling, is it a big hassle? We're on a floating dock. I feel it moving a little. Yeah, if you could talk to that. I saw a bunch of wiring when I walked up the off of it yesterday. And there's a whole lot of electrical, but nowhere near the power you would need.
No, we are working with the Vancouver Convention Centre to be able to access the power that we need. There is power available at the centre for our purposes for the short term. So we are working to bring in a 150 kilowatt charger down here onto the dock. We don't have to do any infrastructure up top, so we don't need any work from BC Hydro, but we will need to wire in the high voltage cables from the Vancouver Convention Centre all the way down to the dock.
So this little cable, right? It's pretty skinny. So yes, I was wondering about it. And obviously that's not some sort of high voltage cable, but you've got on the dock, little 110, 120 volt pedestals. So yeah, what's the function of that at the moment?
So this is actually charging our low voltage system. This was an interesting one from the very first flight. When we first put the aircraft together, we had a DC to DC converter in it to knock down the high voltage to charge the low voltage system. But unfortunately, we had a lot of noise from the DC to DC converter. It created a lot of EMI, and it knocked out the radios.
Ooh.
Which was bad. So we ended up having to disconnect. We couldn't filter out the noise, so we ended up disconnecting that system and installing more low voltage batteries, because one of the problems with this first installation was the cooling pumps were not driven off the engine. They're actually electrically powered from batteries. So our low voltage battery system requirements are actually really quite high. But we couldn't charge them in flight because the DC to DC converter would wipe out the radios. So we actually have 4 ship batteries installed in here right now, and we can't charge it off the big batteries, so we have to charge it off a nice cable like this whenever we're in port. So this is charging our low voltage batteries.
All right, so you own a Ford F-150 Lightning.
I do.
Do you ever hear it, is it a garage and it's parked at night, or?
It's parked in a garage at night.
So do you hear it make noise once in a while when it's topping off its 12 volt battery? So what you're telling me, I'm kind of equating with a car, right? It's once in a while the high voltage pack will go on, and if the car is not plugged into anything, it's got to kind of top off that battery, the accessory battery that.
I have never actually heard of it. Yes, I know that it has to do that, but I've never heard it do it.
But here with the plane, you were saying that was making noise and electromagnetic radio.
Well, sorry,
RF.
when I meant noise, I meant electric noise.
Okay, so you weren't actually
not physical noise.
Okay, that's why you want to clarify.
My apologies. Clarification.
No, maybe both. But, I mean, for a Tesla,
electric noise is what they call it.
Yep. Affecting everybody. Sure, right? I mean, the radio.
As far as it goes.
Exactly. Yeah.
Yeah. So it was conducting or radiating EMI, and that caused the radios to not function properly. And so we couldn't have that, so we had to disconnect that system. It's one of the things we want to do next with this demonstrator is to install a different DC to DC converter and see if we can get that working, because it's going to be required. It's not going to be feasible to continually, every time you come in, is try to charge a low voltage system separately from the high voltage system. It's too difficult.
So let's dive into that noise topic a little bit. Imagine if there's a whole bunch of converters in here and they have a little bit of fan noise. That's not a big deal. The engine turning on. Do you have any idea the decibel level of this thing landing at Oshkosh versus another Beaver that's similar, right? Apples to apples. Similar distance, the camera, whatever. It can be measured.
Yes.
Is it half? Is it two-thirds?
We have measured it. I don't remember the exact numbers of what they were at, but across the board, we were about 20 decibels quieter in every phase of flight.
That's huge.
So takeoff, climb, and cruise. Yes, 20 decibels, as you know, it's not a linear relationship.
Yeah.
That's significant.
Wow.
It's one of the things that we were working on. When we talk about emissions of an aircraft, we talk about both the GHG emissions and noise emissions, right? Because both of those are bad for the environment. And it was our mission to reduce both. And so we went to a shorter diameter prop. It's one of the reasons we went to 4 blades, shorter diameter. And we worked with Hartzell to find the best balance between performance and noise. So we were able to reduce the speed from 2300 RPM down to 1900 RPM during takeoff. And that's why we were able to reduce the noise, because the engine doesn't make any noise. A lot of the noise comes from the propeller. So if you can spin it slower, and if it's shorter, the tips move slower, and therefore you make less noise.
Yeah, it reminds me of a car, an EV on the highway. You're getting a lot of the road noise just from the tires, the rubber hitting the friction.
Yeah.
It's got very little to do with engine whine at that point. It's
Exactly.
drowned out by the road noise.
Yeah.
Plane, similar. You mentioned the tips. So that's part of why it's 4 rather than 3. The speed of the tip
So
is
that we
less.
could have them shorter, so the tip speed is less,
Yep.
which reduces the noise.
All right. Your answer was interesting too, because I was talking about coming in for a landing where you're almost at idle. Would it be maybe half the perceived volume human, right? And you answered with decibels, right? 2 different things really. But
Yes.
20 is huge.
20 decibels is huge, and we have done some testing where we've flown the aircraft overhead at 500 feet, because we can also reduce the speed of the prop even more. It's most efficient in cruise at 1500 RPM, so we reduce the noise even more. When it cruises overhead at 500 feet, you can hear the wind over the flight controls, in addition to the bit of noise from the prop. It's really cool. The reduction in noise is significant.
So pilot reaction to that, if they've never flown a glider plane, which I have, where you feel like you're in a rowboat and you can hear every little thing.
Yeah.
Is the reaction positive? Do they like hearing the flight controls? Like, it's new to them, right? I don't know.
Actually, the pilots love it. They'll say it flies like a beaver. It's a beaver. It still flies like a beaver, but it's quite a sporty beaver. So they really enjoy it. It was interesting though, just anecdotally, coming in this morning when Sean flew in and then landed, as he was taxiing around, he actually pulled the throttle back to idle. So the engine basically stops making noise and the propeller slows down and stops spinning. One of the dock hands had actually thought he'd cut the engine and was getting worried about trying to catch the plane. And then he pushes the throttle back up and the prop starts spinning again. And it was very different for the dock hand receiving the aircraft. And when he landed it at the dock, he asked the pilot, "It's like, I thought you shut the engine off." No, just pulled it back to idle. But it'll actually still be engaged and running, but the prop might not be spinning. It's very different.
That is such a great point. You know, they make you do low noise emitters for traffic safety on an electric car. At a very low speed, have it emitting noise. It's almost like in this situation to be a little safer if the engine was barely on to spin the prop, just to visually show the thing is
so they
powered
can
on, right?
still tell that it's powered. It's one of our identified risks for our ground handling crew, is the fact that it could be fully engaged even if the prop isn't moving, which means a little bump of the throttle, and you have a spinning prop, which is a hazard for the employees.
Exactly. Oh, that's fun that we're thinking all these little details. I say fun. For me, just the nerdy stuff that you've thought through. Obviously, you've been dealing with this for years. I'm just thinking of it as I'm talking to you, but thank you for going through all those little things. That is not a showstopper, right? The comments below some videos I've made, they're the nastiest thing, or this is not even possible, or whatever, right? Looking ahead, what do you think? If you had 6 passengers in this, 2-3 years from now, it's certified. I think you had a year on that billboard there that you're targeting. Was it 3 years out before maybe passengers?
We were thinking 2026 we might be able to get a couple passengers in. 2027 is when we think we'll really hit commercialization with 6 passengers.
Which is defined, success would be 30-minute
success
flights?
For me is an hour mission, including reserve, with 4 to 6 passengers.
An hour, okay. And then how long between flights?
Half-hour turnaround.
Wow, okay.
That's success.
That's ambitious goals. Well, thank you so much for your time. I really appreciate it. This is wonderful.
Converting these aircraft from gas to electric is decarbonization.
So I just started the camera rolling again. We were talking about the year. You said between what years this thing's made?
1947 and 1956 are when the Beavers were produced.
Okay, so 70-ish years later, you're breathing new life into it with a whole new heart and engine, right? And the airframe and all that gets inspected for safety and all that. The engine, how often did you have to do an overhaul before?
So the engine for the piston Beaver is every 1,600 hours, and we're anticipating 10,000 hours for an electric engine.
Huge difference right there,
Massive.
which equates to cost of maintenance. Yep. All right, and soon we're gonna have a look under the hood, literally, as he takes off the cowling there. So we're gonna see electric motor, a whole bunch of stuff around it, charging. Let's see. Does it have any charging components on board? Like the Pipistrel does not. To do extreme weight savings, it has nothing. Just an electric motor and all the electronics.
We had the weight capacity to allow for that. So you can see that box there that I'm showing to you. That's where the plug goes in. So it's a CCS1 plug. You can sort of see it in the side there. So whenever we charge it, we just plug a CCS plug right in there.
Yeah, because you have no passengers and it's a prototype, so that makes sense. So the design goal in the end, would that charging components stay on board, or you're not sure yet, or I don't know?
Ideally, no, it's going to have to be on board to make for ease of use for the dock hands, for the people administering the aircraft. So probably either forward of the firewall or behind the door, we will have a charging port.
Yeah, maybe right here or possibly down there.
Yeah, we haven't decided on that yet.
Figured it out yet.
Will it be CCS, like because the
Yes.
cars are going to J3400 NACS standard? I don't know.
For now, we're with CCS. We might have to use an adapter.
I mean, even details like that, does that change the certification of the plane? Because you said you can't change anything until it's certified to fly.
Yeah.
Does that count? It's such a detail, right?
It's such a detail, but I think we'll certify it with a CCS1 charging port. There are a lot of adapters out there, or they're going to create adapters during the transition period. Who knows? NACS could win out in the end. You never know.
Even your Ford F-150 Lightning is getting an adapter to charge.
Yes, it is.
Yep. All right. Can you point out some of the highlights of what we're looking at a little bit?
Sure. So at the front there, you've got the Magni 500's electric motor.
Way at the front, yeah.
Way at the front. Behind that, you've got the oil reservoir.
Right on top there.
Right on top.
Okay, I see the cylinder,
In there, so that's your oil tank. That provides the coolant that cools the inverters and the motor.
Okay, and they have open air around them, which is kind of unusual. The car's usually really dense and under the back seat or something.
Yep.
And then you've got a couple of battery modules on the firewall.
Yeah.
Is that scoop open on the bottom, actually shoving some air right in there?
That scoop on the bottom goes through a heat exchanger right there. So it's an air-to-air heat exchanger, or air-to-fluid heat exchanger that does the cooling for the motor and the inverters.
Gotcha.
So it's a little radiator on the back side of the scoop in there. And then we've got the two cooling pumps, one here, same thing on the other side. So there's two pumps that run the cooling system for the motor.
And then we recently added air scoops on top to
See
add
that.
additional airflow
So
inside.
put some more airflow through the cowling.
All right, cool. What's bolted to the firewall there?
So these are the battery modules. So
Okay.
there's
I see another one
4
tucked under.
across here, and then there's 2 down there.
I see, yeah,
Yeah.
a little deeper in.
Yeah.
Is that it for battery modules in this prototype, or is there more?
No,
So
there's-
there's these ones
Like where the
here,
picture is, right? A
Yeah,
lot.
where the picture is under the floor in the fuel bay, and then a
here.
stack of them under the charge.
stack under
box.
there,
Yeah.
and a whole bunch in the cabin.
Because they didn't want to assume anything about the flight time or how many kilowatts, or if that's the final one. But yeah, you stuffed them where you could. Maybe it ends
Yes.
up. How many kilowatt hours total? You have any idea?
We are about 156 kilowatt hours.
So more than your Ford F-150 Lightning.
A little bit more
But
than
not
my-
really that much
Not
more.
a lot more than
For
my
6
F-150.
people thrown in the
Yeah.
air. What speed roughly? Do you know?
About 105 to 120 mile an hour.
Yeah, it's not bad. I mean, right? All right. And a plane with giant pontoons, one can imagine the range would be, better without them. Do you think, let's see, do you ever land, some of these have wheels, some of them out there or no, for some of the places you go?
They do make amphibious versions, but then you're paying the weight penalty of carrying around all that
Sure.
wheel gear along with the floats too.
Got it.
We are going to investigate over the next year or so the performance of the aircraft on wheels, so that we would at least have that number in our pocket to say, okay, maybe we can actually get an hour and a half mission on wheels, so that it would dictate for us whether or not we would go through the flight test program on wheels to be able to certify it in both configurations.
Okay. Just thinking about like computers and heat fins that wick off heat, right? You got the Airstream. This is about as hot as Vancouver gets. I guess maybe July or August a little hotter, but this is record heat, right? Today.
Yeah.
Here we are, September 6th,
We're 27 degrees today.
which is 82 or whatever. It's crazy hot. But even on a day like this, you're flying around at 120. If you had just even aluminum fins sticking out or something, it seems like you could wick off a lot of heat. The challenge is the batteries are at different places, right?
Exactly.
That's the challenge. Yeah,
Being sealed in a compartment, it's tough to get the coolant in there.
Yep.
And the problem is that each zone will have different temperatures, right? Because there's more airflow up front, but there's no airflow in the fuel bay area or in the back. So you end up with temperature differentials in your battery pack, which is also part of what we want to address with the ground conditioning system.
So hopefully the manufacturer must value your feedback enormously, right?
Yes.
I mean, the mechanic working on it or whatever. So, well, thank you so much for taking literally a look under the hood. I really appreciate it. It's kind of what my channel's largely about. Computers, tech, whatever. This is really awesome. Thank you so much, both of you, for all your time.
Thank
I
you.
really appreciate it.
Here is seeing The Incredibles. This is exciting because it feels like these cartoons that we see are becoming reality, and I think that is just the coolest thing about the time in which we live. Okay, so slightly different approach. With the eBeaver that you have been working on, Erika, it is a retrofit. And one of the challenges there is that, you know, these aircraft were designed to have fuel in the wings. You don't have that benefit with putting batteries in the wings necessarily. So there's been lots and lots of kind of Tetris issues, but also technical ones as well. Just walk us through the project that you've been working on and where you currently are.
Okay, well, the Beaver actually has fuel in the belly, and so we took the fuel out of the belly. We took the 450 horsepower engine off the front, replaced it with the magniX. It's a 500 kilowatt engine, derated to 336 because we didn't want to increase the power availability. And we replaced the fuel with lithium-ion battery pack. We just changed it out. It's 156 kilowatt hour now. And it is very much Tetris. We have batteries on the firewall, we have batteries in the fuel bay, and we have batteries inside where the passengers would be. Our biggest issue really was that the engine was very inefficiently built, this first generation prototype. So we couldn't put any batteries up front, which meant we couldn't put any batteries in the back to maintain weight and balance. So all the batteries had to go in the middle. So this is purely our demonstrator aircraft for demonstrating the technology, for trying out different components, to determine what architecture we want to go to. Do you want a bus battery system? Do we want a non-bus battery system? How do you integrate DC to DC converters that are traditionally quite noisy? We get to test out all that equipment on our current aircraft. The biggest thing actually with the Tetris issue though is really it's about the temperature differentials we're seeing in the batteries. Right? All the batteries aren't in one pack, so they don't all rise and decrease in temperature at the same rate. So that's one interesting effect of doing a retrofit, is trying to figure out how you manage those temperature differentials, and for us that's really going to be all about our ground conditioning system. So I think over and above the charging issues we're going to have, it's going to be about bringing the aircraft into the dock, plugging into the charger, and plugging into a ground conditioning system to ensure that we can dispatch the aircraft at the appropriate temperature and that all the batteries are within X amount of temperature to each other.
And I also understand that beyond just the technical challenges that exist, because it is a retrofit, the approval process has been really complicated, and that's not a problem that's unique to your experience, but just generally. Why does it take so long?
The real issue is that the regulations don't exist for this technology, and until they actually brought in the latest rules, nobody will know what it means, but they brought in performance-based rules, which is allowing industry to help develop the standards we need to meet. So that actually has been really beneficial, but in Canada, Transport Canada didn't even adopt that performance-based rules until 2021. So we couldn't even apply for our project to move into an STC or certification until after that was approved. And from there, the standards haven't been built. All the different companies, a lot of the ones that you mentioned, they haven't come to agreement on what is the bar and what do we have to cross. What do we have to do with batteries? What do we have to do with thermal runaway? Do we have to contain it? Can we mitigate and manage and prevent cell-to-cell propagation, or do we have to just do containment? Is it a combination of both? How do we test it? What does that test look like? We have to get to agreement on that, but not only do we have to get agreement on that within industry, we have to get agreement with the regulator, and it's not just one regulator. They don't want different rules for Canada than the United States, than Europe, and Brazil. All four of those major civil aviation authorities are actually meeting constantly to talk about it, but none of them are on the same plan. So there's so many different things, and that's just to get the regulations and standards set, and then we have to show that we meet them. So that's part of why it's taking so long.